Welcome back to another episode from Pro Engineering. Now in this episode, I'm in the middle of like 4 or 5 other projects, but better. Shove those aside because none of that matters anymore. This is SuperFly 3.0. Well, I mean, it's the pieces of SuperFly 3.0. We have to build it still, but I just could not wait to rip these out of the bags from Shapeways and paint it and throw this thing together as soon as possible. This is something that I've wanted to do since probably 1994 as a little kid, and it's finally happening. So a few things before we get painting. What I wanted to point out is I designed SuperFly 3.0 with as many Pro parts in very Tamiya fashion as I could. So for example, SuperFly 3 will use the leftover bits that I had here. Okay, the standard Pro 20mm offset front suspension. It'll use the standard Pro battery retainer. Now, this is the version for SuperFly 1.0, which doesn't actually have the trans brace. These are the uprights, the Pro battery door. This is another leftover part we don't need. The SuperFly 2.0 rear suspension arms. SuperFly 2.0's shock mounts for a 16th scale HSP shock absorber. This is the standard stock Tamiya Hornet body Pro cage. This is the standard Pro rear wing mount. I wanted to reuse whatever I possibly could because there's a lot of folks out there that already have a lot of my products. So if I were to design a new cage and new suspension and a different battery door, then the ability to move from a lower cost build to a higher cost build makes it that much more expensive because now you've got a lot of unique parts. That is not the case here. So there are a lot of reused parts like the cage. Just try and pull this back off here actually. But there are quite a tremendous amount of new parts as well. So this transmission is for a complete double wishbone rear suspension. Geometrically, it was quite complex to get to work in this lower area, mainly because I wanted to pull the rear track in to allow the car to use the factory Hornet tires at the rear. This means it requires a modified rear rim to get it to fit all the geometry and all the suspension components in there. Now in this case, we are using SuperFly 3's chassis, and this is a complete, I'll pop this out real fast. This is a space frame chassis with a very large battery enclosure. And again, the Pro battery door fits in there. The battery tray area is no longer offset like it was in the Hornet. It is centered now. This whole belly pan piece here slides off. And you'll notice as well that there's, well, I guess offhand, it can look like needlessly numerous parts. So for example, this mount here is where you would mount the front A-arms, but it also acts as the bumper mount. So the bumper will mount in the center point here as well as here. The reason for that, it is very common to find Tamiya Hornets with this mount broken. If this had been integral, then if you break this mount, you throw away the incredibly expensive chassis. So I wanted it done so that if you did break this piece, you just toss that to the side and replace that part. And the same is very true for the front shock tower. It's incredibly common to have a Hornet with a broken tower. Now the front shock tower is separate. It mounts to these 2 points on the cage and to this point here on the center mount. So now the cage, or the, I should say the cage, the tower will come in there. Should you break this, get a new one. Not a big deal. Anything that you see in gray here is a very, very high quality Hewlett-Packard derived 3D print. These are ridiculously strong. I really, really like these parts, but they do cost more than the nylon. And volumetrically, when you get to larger parts like this chassis, it becomes very, very cost prohibitive. Again, this is a space frame chassis, so that will come out. This entire lower piece here slides out. Theoretically, there it goes. It's only 2 mounts back here, 2 at the front, and then the little clip here on the sides. But that is basically the entire chassis. Here's the front piece. Okay. And then the rear. Okay, that's all out. The one thing I want to mention about this is that if you use the rear suspension, the Ampro rear shock mount, just like this. All of this will bolt into a standard Tamiya Hornet chassis. Anybody out there wanting to do this to a Grasshopper, it's going to work as well, but a lot of cutting at the rear of the body will be necessary. I will go over this in the part of the video where we assemble this, not anymore until then. This will be a multi-part video. Right now, what I want to do, paint all of these bits because there's a lot of them. You'll notice one thing that's missing if you are familiar with Ampro 1 and 2 is the body. Well, the funny thing is with this project, I almost want to hide the fact that this is not a Tamiya product. We are going to use a few bits from the Tamiya, like the gears in the gearbox, the front hubs, the Nerf bars, and some parts for the axles and half shafts. But otherwise, this is a completely Ampro product. The thing is, I want it to look like a Hornet. The complete goal of this project is to build this car, put it all together, put a Hornet body on it, and no one will be the wiser that it's not a Hornet. And that's the goal here, is that look of the Hornet was something that I always loved, and that's what I wanted to keep. So let me paint all these pieces here, and we'll be right back. I went ahead and painted everything that I wanted to paint, and I just couldn't help just kind of slapping it together a bit to see how it looked, but I think I should tear it back apart, and I just stuck everything there. Nothing's actually screwed in place. As I assemble this, I'm going to do the best I can to assemble it in the right order. Now, obviously, I designed this, but designing it and assembling it may be two different things. You know, I have an idea of the order that it should be assembled, but we won't know until we're there. Step 1, install the body mount right there. First, we'll start with the front bulkhead, and I believe, so that'll go first, and then that goes on top. I tried to keep a lot of the geometry that the Hornet had because I still want this to give the impression of being a Hornet. Well, we're going to use 1, 2, 3, 4 M3 screws. Let me just get my bin of screws out. You'll also note here that these screws have to go through this first, so that will all go in there, and that basically means you got to put the A-arms in. We're going to use the Ampro 20mm offset A-arms. There's 1 and 2. These are the exact same ones I've had for sale for quite a long time, so those are in, and that goes there. For this, we'll use 4 12mm long self-tapping screws, and it'll just kind of go straight through until it hits the bottom one, where you will tap it on in. Okay, these should not require any drilling if you're going to use the Shapeways SLS nylon, as that is how I've intended them to be. If you are going to print these out on your own machine, you may need to clear these out using a 2.5mm drill bit, and that's going to be with all of these holes that you tap into. So in the event that these, if you torque them down too much, or if the screw doesn't seat properly and it strips, you can use a machine screw here and just put a nut on it. Before I put the rear ones in, I'm going to install the bottom skid plate. And the way this works is it has these 2 hooks, 1, 2, that hold it in place. There's 2 screws at the front, and then there's 2 here at the rear, and we'll use those later. But for the time being, you just press it down there. It flexes a little bit here at the center, but again, this is nylon and shouldn't have any problem. And oh wow, it's in. Okay, well, there you go, it's in. That'll be a little bit harder to do, but no, it's in there. So now that those 4 are in, we'll install those 2, as well as the 2 to hold the skid plate on. Those will also be, yeah. I'm going to keep calling out self-tapping 12mm long screws because they're incredibly common. And for this application, once again, you're more than welcome to use a machine thread screw with a nut on the other side. You'll notice that I did not tell you to screw this in, and that is because we have to put in the steering arms. Now, this is complicated because Ampro, what can I say? We're going to use quite a number of these 8 by 5 by 2.5mm bearings. I believe 6. We're going to put 1, this is just the most ridiculous thing. We'll put 1 there. There you go. 1 on the back side. And the reason why I did all of these is because A, Ampro, why not? And B, these are 3D printed parts, and it's really going to be impossible to rely on these parts to rub together smoothly. So you're going to have something else that is providing the motion. So that's where all those are going to go. These are going to go here somewhere, And then there's another piece right here which connects the arms, and that is where the other two bearings will reside. I really hope this works. I've only simulated this in CAD. Before those go in, we have to install the ball studs. And it is in this orientation here, and this one's on the, looking at it from the driver's position, this will be on the left side of the car, and we'll have one ball stud here. These are Tamiya ball studs. There's the gold ones, M3 at the base, then I'll put a nut here at the back. We will also need one here at the bottom, so there's 3 of these, and one here at the bottom of this as well. So now that those are installed, we can set the right one on, just like that. The left one, which will go like this, and then those two are connected like that, probably. Yes, like that. And you've done this right. I hope I've done this right. You know what? I may need to clean this out a little bit. But basically, you want the top of this inside portion protruding, and right now it's not. I would suspect that there is residual support material inside this. Now, before you put the bearings in, you want to get your X-Acto knife and just run it along the inside corner. The problem is that is usually where support material doesn't get cleaned off enough. So just get it in there, clean it out a bit. Now you have a nice sharp surface to install the bearing on, and you want to do this to all the areas we're going to put the ball bearings on in this video. Please be careful. When you're done and you've done it right, the bearings should be just about flush. If they're not flush, then when you install them here, this feature is not going to protrude. This little boss here, it has to protrude just slightly like that. Otherwise it'll bind up. To assemble this, you'll need 4 washers, 2 12mm long self-tapping screws, and 2 8mm long self-tapping screws. They cannot protrude out the bottom. And this is what you'll have when you have it all done right. I found that if I tighten these down, it was a little bit snug to turn, so I backed a couple of these screws, a 1/16 of a turn, and they were fine. With this nylon, you're not going to find these screws backing out, so just don't over torque them. You do not want to strip the holes out, because then you're going to have to use a nut. But on the back of these, I don't think that's even possible. There's a lot of, basically you'll hit the A-arm right here. We can now install this very simply. It goes in this orientation, and it drops right there on the rear. See that screw hole and that screw hole. It goes on the rear ones just like that, and you use a 12mm long M3 self-tapping screw to hold those in place. This will be held in place by a 12mm long screw and an 8mm long screw. And it has occurred to me that it's a little bit hard to get your screwdriver in there, so perhaps I should have installed this later. So just a heads up, put this on afterwards. Let's install the servo. This is the servo plate, which will drop in there, slide back, and get held down by that screw and that screw. What is this third screw for? I don't remember. The thing is, given the body and the width and all the spacing in here, a standard servo does not fit. This one does. It's not standard, it's a slightly smaller, and will go right on there. I simply have no intention of using a standard servo for such an application. There's a lot of issues with depth and width, and it just wasn't worth it. So this is called the K-Power DM0260 digital servo. I'll have basic dimensions of this. For the production model of this part, it will come with the standoffs attached to it. In Shapeways, they'll be separate parts. The servo must be mounted as low to this as possible, otherwise it will come into contact with the roll cage, which goes right above it. For the bottom, you'll want to use a flathead or countersunk screw, and just note, flathead and slotted type screws are very different. Flatheads and countersunk screws sit flush with this surface. You'll probably want to use probably nothing more than a 6mm long flathead, and those are measured like this. That is the length of one of these flat or countersunk screws. 6 to 8mm is fine. There we are, nice and flat. Center the servo and then install the Servo Saver. The servo is all ready to install. You can have it kind of pan through its cycle there. It's going to be way more travel than we need. But now that that's all ready to go, we can just slot it in, and you can see that it has these little fingers down here that hold it in place. So that just slots straight in there. I had to drill a hole in this Kimbrough Servo Saver because it did not have a center mount for the ball stud. The ball stud is, again, another standard Tamiya M3 ball stud, and I did have to put a regular nut on the backside, not a lock nut, as it won't fit. To hold this down in place, use two 12mm long screws from the inside to hold those in place. This was done this way to prevent anybody from putting a screw that's too long in from the other side and potentially hitting the battery. Now, I have covered the A-arm installation on another video, but we'll just briefly talk about it high level here. There's a link right now to the main video, but that is a screw pin that you put straight through here. You're gonna have to drill this whole rod out with a 3mm drill bit. The spindle you will need for this kit, and you can use either the screw pin that the Hornet donor car, if you have a donor car, came with, or you can just use a 3mm rod, and there's an M3 set screw at the back that you can just torque down, which is what I've got here. These are designed for 2mm shank ball studs. I went ahead and drilled these out to a 3mm shank, which makes them pretty thin here on the outside, but I haven't had any problems in the past. But I'm a kind of conservative driver. Perhaps one day we'll model this thing in nylon, but right now I don't have that. I'm going to interrupt for a moment with the production SuperFly, and you can see that I have in fact designed my own version of that little steering link there. You still will need the donor for the spindle that the nut, see here, attaches to, so you will need that. Not only is it a bit thicker, but it also will allow you to have a 3mm ball stud attached to it. The geometry is also a little bit different because it will allow you to increase the steering throw. So that has changed. You don't need this one, but it is an option, and it will be included in the My Mini Factory package. A ball stud here with a 3mm shank. We'll need corresponding ones up here later on, but the roll cage has to go on first. And now we can add all of the tie rods. It's going to be very difficult for me to tell you how long they have to be, simply because I don't know. It's all going to be dependent on the type of ball cup you use. The best thing I can tell you to do, which is what I do, is buy some 3mm all thread and simply cut to length. I believe the diameter of these ball cups are, round about, I think they're known as 4.8. This is 4.7 almost. I think they're 4.8. If they're difficult to find, you can always buy ball cups that come with the ball studs, or you have the captured ball cups, which again come with a screw, and you can simply use a screw instead of the ball stud. Even though the installation of the tie rod ends are going to be a pain in the butt, we have to install the front shock tower. For this one here, you'll need a 8mm long self-tapping screw, and for these, you're going to come up from the bottom from here and tap into these with I think a 12mm will be fine. Part of me feels that a machine screw would be best suited up here, but this is all that new HP Fusion printer, so I want to test that out. So in the meantime, we're going to use a self-tapping screw. We can at least install some shock absorbers now. The shocks I like to use are these HSP units. Usually they're really, really good, but it just occurred to me that these, you can see these are in package still, did not come with the little aluminum piece that goes in here that allows for the pivoting, which, I mean, it's not that big of a deal, but it's still, like, you see at the bottom here, it's got it, which is very annoying. The good news is I think I have a solution. So what I did is I took it out of the bottom and put it in the top. And you might be thinking, well, what about the bottom? Don't worry, because we have these. So these eyelets, I simply drilled out the hole with a 2mm drill bit and then tapped them with a 2.5mm bottom tap, threaded them straight in, and they're good to go. In here, we're going to install a sleeve. Tamiya has these brass ones in a lot of kits. If you don't have that, you can just get one that has a 3mm inside diameter and a 4mm outside diameter, then cut them down to fit. So here's the sleeve. You don't want to force these in. I've seen people that have just kind of jammed them in and actually broken and actually bent the brass. So there's a little bit of residual there we'll take off, but that's what we want. Because we have this nice sleeve, for the screw down here, we can use a machine screw as long as you can put a nut on the other side, or if you've got enough, you can use some of the screw pins. You will want a machine screw at least 32mm long. Shocks are installed, and I went ahead and used an M3 screw. This is a 33 or 34mm long screw, around there. These are lock nuts, and they have to be lock nuts because you cannot rely on the compression of the nylon to hold this in place. If you do, you will lock the shock in place, and it needs to be able to flop around, otherwise your suspension will not work. At the top, you have a couple of options. If it came the way you saw earlier, you could put another sleeve in there and run a 3mm long screw. Because these holes are 2.5 millimeters as it is, I'm just going to run a 2.5mm long screw straight through that and we'll be all set. The front shocks are installed. I used two 2.5mm washers, and I used a little spacer that I found, but I suppose a couple more washers would have done the trick, and that centered it nicely. This shock tower is intended to use that same brass spacer at the bottom, which would have worked fine had I not used that captured ball in the top of the shock. So there's a couple of options there for you. So I think at this time, I'm going to stop the video now before it becomes 6 hours long, and we'll pick up in the next video working on the center section of the car and then get to the back half. Thank you all so much for watching, and I hope you are as excited as I am. We'll see you next time.